Good evening, everybody. Welcome to the Marston Theater Virtual Night Sky, presented by the School of Earth and Space Exploration at Arizona State University. Welcome, everybody. This is a every other Wednesday night program. I'm glad to see a lot of people have joined us tonight. We're going to talk about a lot of things, but before we go forward at all, I'm just going to do something a little bit different. Things got a little wild around campus last Thursday, and I just wanted to show you this video. I hope you don't find it disturbing, but it kind of sets the tone for what we want to talk about tonight.
Whoa! Good man.
All right, so what's that man so excited about? The guy that was featured in that little video clip was Dr. Jim Bell. He is the principal investigator for Mastcam Z, which are two cameras that are on board the Perseverance rover. And I hope everybody had a chance to watch that. If you didn't, I hope you're up on it, right? The news has been full of information about the rover, what's happened since it landed, and the success of the landing. And we at ASU are looking forward to sort of the images and processing the science as it comes down. What you saw there in the video is behind that glass, there is actually a mission control right on campus. And when we open again, and you guys get to come back and visit us, that was in our building, and that's a public place. Not now because we're closed for the pandemic, but when you come back, that mission control there, and then all those young ladies and there's that were operating, sitting behind cameras in there, they're actually receiving data. They're actually operating the cameras on Mars, and you can see they were pretty excited about the possibilities and what we're going to be able to learn from Mars, from the Perseverance rover going forward. So that was really quite an event. We're all still kind of excited about it. So here's what we're going to do tonight. First, let me introduce myself. I am Rick Alling, and I'm the manager of community outreach programs at the campus. Of course, during COVID, we're not at the campus right now. So we're broadcasting and doing these virtual night skies every other Wednesday just to keep in touch with you, just to kind of keep a good dialogue flowing and keep you interested in some of the things we're working on and some things to look for in the night sky. We're going to do that tonight, too. Along with me is my colleague, Meg Hufford. She and I are the two that conspire to welcome visitors and have school groups and have all that stuff happen on campus. And so now we're learning how to do that otherwise. If you are an educator, if you know an educator, please understand that we actually are using our technology and delivering it right into classrooms during these conditions where school students are not going to classes and they're operating out of their homes. So we're still doing that for sure. Kim Batista is on the line tonight, and she is your webmaster. She's the one that sets up these programs, gets them organized, and communicates to you. And the three of us are the staff members that are part of what we call a community outreach team, of course, working for the school and Arizona State University. Lots of students here tonight. We gave Alicia the night off, but Spoo is back, and also Alex Blanche. You've seen them often enough. Justin Baez is joining us tonight, and he is going to be kind of helping with field questions in the background, and he will be hopefully a presenter at a later date. So he's just an observer tonight. And then a new student you haven't met also is Pauline Camacho, and she is actually going to deliver for you a PowerPoint presentation just to get you up to speed on the overview of the Perseverance rover and the mission and what it's doing. And we'll spend about probably the first 2/3 of the program about Mars and the mission. And then the second third of the program, or the last third of the program, I'm just going to get you up to speed on some things to look for in the night sky and something to look forward to 2 weeks from now. We're planning a program that I think will be a lot of fun and very interesting. So with all that, we're going to get started. I am going to introduce Pauline. She's going to share her screen with you, or I'll let her introduce herself as well and tell you what she does and how this works. And she put together a really nice, concise presentation just about perseverance and what it's going to do and what we expect from perseverance. And it's a great way to set up the program tonight. So let's welcome Pauline Camacho. Thank you, Pauline.
Hi, you guys. All right. So my name is Pauline Camacho. Just a little bit about myself. I am a fourth-year student here at Arizona State. I'm studying percussion performance. So basically what that means is I just play the drums all day long, and I play marimbas and xylophones and tambourines just all day long, and that's just what I do. And I study it and I love it. Cool. So let me just share my screen really quickly. All right, so you guys can see that. Cool. All right, so even before we even start talking about perseverance, I did want to talk about just a little bit on my part. I'm not actually a STEM major. I'm not a science major. I'm a performance major. So I do a lot of things with the arts. But I also wanted to let you guys know that I also do a lot of things with science. I work at the School of Earth and Space Exploration. I give tours to any classroom visits and stuff. So I just wanted to let you guys know that just because you're not in science, or just because you're not studying Earth or space, that doesn't mean that you can't study anything else here, right? Like, there's a lot of things that require the arts in space. For example, graphic design, website making, composing music for videos. Like, that is all still involving Earth and space exploration, but you're just making it your own way and you're being creative about it. So just wanted to let everybody know, even before we started talking about perseverance, that just because you're not a science major doesn't mean that you don't have to not study the Earth and space. Okay, cool. Let's keep going. So my presentation is on the Perseverance rover. So really quickly, I just wanted to go over the rover that kind of inspired Perseverance. So this is the Curiosity rover. It launched November 26th of 2011 and arrived on Mars August 6th of 2012. It took about 9 months to get there, just because Mars is so far away from us. It has 6 legs, 1 arm, 17 eyes, and 11 different instruments. So the 6 legs are the wheels that you see on the side of the picture right there. The arm is going to contain all of the instruments, and then the eyes are just the cameras that surround the rover. One really cool thing that we will be talking about later on in this presentation are the Mastcam cameras, but there are Mastcam cameras here on the Curiosity rover as well. They're located under the big eye of Curiosity, when in reality it is also not an eye, it's a laser, but we'll talk about that as well. They're the 2 square cameras right under it. And what's really cool about those cameras is that our very own professor and planetary scientist, Dr. Jim Bell, is actually working on those cameras currently, and then also working on the Mastcam Z cameras for the new Perseverance rover. So it's really cool that we have a professor here at ASU that's still doing work in their field. It takes panoramic photos, just like the one you see, and Perseverance does the same thing. And then my favorite thing about Curiosity is actually a cute little fun story. So you can't really tell in this picture, but the wheels have 3 little holes in each one of them. And the company who made the blueprints for the wheels, they're called JPL, or Jet Propulsion Laboratory. And they actually like to put their logo on anything they make, just to show that they made it, you know. But NASA decided to not put any logos on the Curiosity rover, keep it clean. It was a contribution from multiple different countries and areas from the world, so they decided no logos. JPL decided to not follow that rule, and they decided to put their logo on the tires. So the way they did that is they put these little holes in the tires, and when NASA saw what the tires were for, they were like, what are they for? What are the tires for? And JPL told them that it was so that the rover could go over sand and rock easier, which is true. It does help the rover do that. But what JPL didn't tell NASA is that those holes are actually Morse code for JPL. So every time that the rover is actually moving on Mars, it's actually printing the letters JPL on Mars. So they kind of tricked NASA there, but by the time NASA found out, they couldn't really do anything. It was one of those like slap on the wrist kind of things. But yeah, that's my personal favorite thing about the rover. Cool. And this is the Perseverance rover. As you can tell, it looked very similar to the Curiosity rover that we were just looking at. It was actually kind of inspired from that rover as well. So there's going to be a lot of similarities that you might be able to see. Cool. So really quickly, we're going to do a quick little mission overview. So the main job of this rover is to seek signs of ancient life and collect samples of rocks, and then hopefully collect them and bring them back to Earth, or hopefully we'll be able to bring them back to Earth with a future mission. It launched July 30th, 2020, and it landed February 18th, 2021. So, last Thursday, I think. The landing site is Jezero Crater, which is where the little picture you see right on the side. It has 4 main objectives. It has a geology objective, an astrobiology objective, a sample catching objective, and a preparation for humans objective. So what those means, the geology objectives is going to study the rock and landscape of its landing site to see if we can reveal any kind of history from the region that we haven't been able to see. The astrobiology part, which is the study of life on Earth and possibly in space, is going to determine whether there's an area of interest that was suitable for life, and it'll look for ancient life itself. Sample catching is going to find and collect promising samples for hopeful return to Earth from future missions, and then preparation for humans. So there is a lot of cool new and improved technology on this new rover that's actually going to help us determine if we're able to sustain humans on Mars. So this specific rover is super important because of that. There's just new technologies that we're testing on here that will hopefully let us eventually have humans on Mars, right? Which is the goal. Cool. So the way we're going to do that is by using these instruments, and we will be talking about all of these instruments today. We have the Mastcam Z camera, the SuperCam, the Meda, Sherlock, Pixel, Moxie, and Rimfax, and we'll go into detail with all of them. So the first thing we're going to talk about is the Mastcam Z cameras. The Mastcam Z cameras, its main job is to take panoramic and color photos, 3D images of the Martian surface and its features. So it has the power of zoom, which is going to tell us if there are going to be any rocks that could preserve signs of life. And it'll also look for rocks that we're able to sample and core and catch, and then obviously hopefully return to Earth. It'll look for water signs. So it'll detect signs of ancient lakes, streams, and other related water features. And the Mastcam Z is all seeing. So because of how powerful the zoom feature is on the Mastcam, it can see about the size of a housefly all the way across a soccer field. So just imagine you're standing on one end of the soccer field and you see a fly on the other end. That's how powerful the zoom is on the Mastcam Z cameras. And not only is this camera just super cool in general, it's even cooler that our very own, again, Dr. Jim Bell, our planetary scientist and our professor here, is a lead investigator here. So again, I just want to reiterate, it's not a lot of professors are doing work in their field, and it's really cool that one of the professors here at the School of Earth and Space Exploration is actually currently doing work in their field, which is super cool. All right, let's keep going. Cool. The next thing we're going to talk about is the SuperCam. Its main job is to identify the chemical composition of rocks and soils, including their atomic and molecular makeup. So what that means is we'll be able to see in the individual atoms, like for H2O, for example, we'll be able to see the hydrogen and the oxygen as well, which is crazy cool. It'll look at different rock and soil samples to find ones that could preserve signs of past microbial life on Mars, if there ever was life on Mars, because again, we still don't know that. And then the SuperCam can fire a laser that will be able to study rock targets smaller than a pencil point. And it's able to do that from more than 20 feet away from the target. This is really good for us because there's a lot of places where maybe the rover can't get somewhere, and if the rover can't get somewhere, we won't be able to study it, kind of thing. But now we'll be able to because of the laser on the SuperCam, and it'll be able to see from 20 feet away. Cool, let's keep going. So the next thing we're going to talk about is called Meda. So Meda stands for Mars Environmental Dynamics Analyzer. Its main job is to measure dust and monitor dust with sensors from the surface of Mars. So this specific instrument is kind of like a weatherman, right? So those two little prongs at the end, that's what the Meda is. It's going to tell us the environment of Mars, and it's also going to tell us the weather impact on the rover. So we have this specific instrument because we want all of our explorers to be safe, right? No matter how old you are, and even if you're not human like our rover, right? We want to make sure that our rover is safe in no matter what environment. And it'll also benefit us because we're trying to see if us humans are able to be on Mars with the weather that it's at right now as well. Cool. So the next thing, and probably my favorite thing on the rover, is Moxie, the Mars Oxygen and Pseudo Resource Utilization Experiment. Its main job is to produce oxygen from the Martian carbon dioxide atmosphere. So I'll repeat that again. It makes oxygen on Mars. That's pretty much what it does. And it is just a test model. As you can see, it's located inside of the rover. It's pretty small. In order for humans to actually be sustained by the instrument Moxie, it has to be at least 100 times bigger to support any future missions with humans to Mars. So this is obviously just a test model, but if it works, it could be really, really good for us and a very big step into sending humans to Mars. So it works just like a tree, right? It breathes in the carbon dioxide and it breathes out the oxygen. So this is going to be something that we should all, at least I will be on the lookout for updates and stuff, because this is going to be a good big leap for us in trying to see if we could ever send humans to Mars. Cool. So the next thing we're going to talk about is the PIXL. It stands for Planetary Instrument for X-ray Lithochemistry. Its main job is to measure the chemical makeup of rocks at a very fine scale. So what that means is we'll be able to look at things at much smaller scale that humans can't really see with their eyes. It's not very large. It's about the size of a lunchbox and weighs about 10 pounds, which is very, very cool in itself, because we actually have instruments on here on Earth that do exactly the same thing, but they usually weigh about 500 pounds. So the fact that we were able to compress it into a little lunchbox that weighs 10 pounds is very, very impressive. Also, it's going to detect signs of past life. So the way it's going to do that is detect signs of past life. I'm sorry, microbes, they change the texture of chemistry and their environment. So basically, think about when you go to the dentist, right? And they're scraping the plaque off your teeth. That hard stuff is minerals left behind by millions of bacteria, and it's an example of a biofilm. And biofilms form when a group of microbes, they stick together to form to a surface. And you can find biofilms on surfaces everywhere in nature. So PIXL is going to be able to detect signs of biofilms made by microbes in the Martian environment from long, long ago, which is going to be very, very cool. Let's keep going. Cool. So the next instrument we will be talking about is called the RIMFAX. RIMFAX stands for Radar Imager for Mars Subsurface Experiment. So the main job is to see geological features under the surface with ground penetrating radar. So it will be able to detect ice, water, and salty brines for more than 30 feet below the Mars surface. And this is the same technology we use to see into the Earth's crust, right? Or possibly into the mantle, but for now the crust, because we can't really dig all the way through the crust. So we use a machine just like RIMFAX to help us see and look what we can actually see. It'll give us, because it can see structural details, it'll give us a new view into Mars's ancient past, when different kinds of fluids and rocks had settled on top of it and are now buried. So we'll be able to see deep underground with the RIMFAX instrument. Cool. The next thing we will be talking about is Sherlock. Sherlock stands for Scanning Habitable Environments with Raman and Luminescence for Organics and Chemicals. Its main job is to fine-scale detection of minerals, organic molecules, and potential biosignatures. So Sherlock is located on the arm of Perseverance, and it works all day and all night. So it's always working. And it's also no touch required, which is a good 2 thumbs up in our current state right now. So what will happen is Perseverance will actually move its arm right over the target, specifically 2 inches over the target that it wants to collect data from. And it will just collect the data from just observing it from above, and it doesn't actually have to touch it. And this is going to be super important for us because when we touch things, we tend to contaminate them. Like if I were to touch my water bottle right now, I would contaminate it, even if I weren't trying to. So the fact that we will now be able to collect data from rock samples without even touching it is going to be super big, so we don't contaminate the rest of the rocks there, right? Sherlock will use ultraviolet laser light to spot organic chemicals, and it works the same way as like a modern like crime scene investigators, and they're looking like for forensic clues. It kind of works like that. The last thing it'll do is it'll test spacesuits. So it'll actually carry a little fabric in there, because like I said, we want to make sure that all of our explorers are safe, human and robotic. So we are making sure that our robotic explorers are safe by using our little weather machine, right? But also, we're also making sure that our human explorers are safe as well by making sure the suits, the fabric that our suits are made out of, are able to withstand the Mars environment, because we just want all of our explorers to be safe, so we take extra precautions. And that's about it. Thank you guys. I will stop sharing my screen now. Beautiful.
Pauline, thank you very, very much. That's a really tremendous overview, and I'm old enough that I can't keep track of acronyms anymore, but you just rattled them off like they're supposed to be said. So good job with that. It's an amazing instrument. It's an amazing rover, and one of the things that we'd like to characterize it as is it really is a biological laboratory. It really, and on wheels, and it's moving around. But there is no substitute for having samples at home. And so, as Pauline was saying, making a big deal about our ability to collect things, leave them in piles or in places. They haven't decided where yet. That'll sort of be something that comes with the mission, and leave those samples for a future mission is going to be pretty exciting. So, very good. I forgot to mention that we will have. There is an ability to ask questions along the way. Our chat is disabled, but you can go into the Q&A function and make comments or ask questions as we go along, and many of the students will answer those questions as we go. And then we will take a break after a bit. We've probably got about another 15, 20 minutes. We'll take a break and we'll take some audience questions live or on the air. We also have some polling questions coming up for you later in the day. So you better pay attention to what we're talking about, because you're going to be asked to answer some in a little sort of mock test. The other thing I forgot to mention is that we are closed caption streaming this particular program. So we're using the technology to kind of keep track of what we're saying and turning out a transcript. You can actually turn that on or off. So it's up to you. Your screen will toggle it on or toggle it off if you want to use it or not. I want to make sure you do that. I'm going to share another screen now. We're just going to talk about sort of Mars and Mars's relationship to Earth. We're going to kind of go right to the surface of Mars. I'll show you a little bit about where all these spacecraft land and where they go, what they're looking for on Mars. And then I'm going to share with you a website that is just getting populated every hour with new images that are coming down from Mars. I'll show you exactly how to get to that and see how to use that and follow the progress of our work at ASU, but also the mission in general as we go. Let's see, sharing screen. I have to optimize, always remember that. So you should be seeing a little bit of an inner solar system view here. There you go. What you see here is the orbits of the inner rocky planets, the ones that sort of like include Earth and Mars, the ones that have surfaces that we can land on. Fortunately, Mars is one of the closest planets to us. Let me just kind of take you back a little bit. This is the relationship of Earth and Mars tonight. This is where they are. And if I go back, I'm just going to go back to when these missions launch. See Earth is sort of like passing Mars there a little bit, sort of like getting back and going around the corner a little bit. I think I have caught up. So let me just show you a little bit here. The way the orbits work is Mars orbits the sun much slower than the Earth does. In fact, it takes a little bit over 2 years of Earth revolution to get back to sort of a location next to Mars. And we want to launch missions to Mars when the Earth and Mars are close to each other. We've talked about this last year at launch time, and this is just sort of a little recap of some of the things we talked about. And so Earth is going to go in this direction, sort of around the sun. Mars is going to go around its direction. Let me just kind of go back to today so you can see what that looks like. I'll do a little 12-second move forward. When we are closest together, that's a point where we call opposition. Sorry, the computer's a little bit jerky on and so the spacecraft landed on Mars last Thursday. It took a little bit less than 8 months to get there. We launch when we're getting near opposition to Mars. We arrive when we're past opposition to Mars. And it should be no surprise that we're the Perseverance Rover, the Mars 2020 mission that includes the Perseverance Rover. It was not the only mission to Mars. In fact, the country of China also had a spacecraft arrive about 2 weeks ago, and the United Arab Emirates also had a spacecraft that arrived about 2 weeks ago. ASU also has an instrument that is on the UAE spacecraft. So both of those UAE, it's called the HOPE mission, and the Perseverance rover includes sort of ASU fingerprints. And that we're very proud of that. And we're talking a lot about Perseverance tonight. That seems to be the big star, but we can't forget that other orbiter is there. The HOPE mission is not a lander, it's an orbiter, and our instrument on board is an infrared spectrometer. And so what we are doing is measuring heat signatures that are sort of in the atmosphere and off the surface of Mars. The HOPE mission will be the most important mission for characterizing the total of atmosphere on Mars that ever has been. There's so much about that atmosphere. We know some about it, but there's so much about it we don't know. We don't know how much of the atmosphere is escaping into space. We don't know the distribution of dust storms and how they work and how weather works on Mars. That particular mission will help us understand that, and ASU's instrument, a spectrometer, will help with the science of that mission. So that's really kind of cool. Before I leave this view, I'm just going to twist you over a little bit here and show you when we look at Mars. I'm going to just go right down to Mars here in a minute. But before we do that, I just wanted to show you something here. From the Earth's point of view, let me do something here real quick. I'm going to center Mars in the screen. from the Earth point of view, let me get the just right. Yep, there you go. So we're looking out into space. You can see we're looking in this direction from Earth, and in this little object way out here in space. You see that? You guys probably will recognize it if I tell you what it is. That's the Pleiades. And so later in the program, at the very end, I'm going to give you some night sky things to look at, and just remember this little conversation we had: Earth and Mars, and the direction we're looking, and Pleiades in the background, and you'll see how that relates in a minute. All right, I'm going to go down to Mars now. Let's go. You guys didn't know you were journeying to Mars yourself tonight, did you, before we started? As we get a little closer, I think some of you might know that Mars has 2 little moons. The moons of Mars are nowhere near as big as our moon. They have names. They're called, there you see them in the view there. They're called Deimos and Phobos. You just see them a little bit in the background there, and they're about the size of asteroids. In fact, I guess probably some scientists think they are maybe asteroids that were caught by the gravity of Mars at some point, and sort of now are just orbiting Mars as little baby moons. It's kind of fun because sometimes our spacecraft, our rovers on the surface, can use their cameras and take pictures of the moons of Mars. So that's a little bit of a kind of an interesting thing. Mars has features. That's the other thing too important. We've known this early on. Oh goodness sakes, when telescopes got big enough and strong enough to see the surface of Mars in some detail, early scientists knew that there was these dark splotches and lighter areas. They characterized them kind of funny in the old days. Some people thought that there were canals on Mars, like as if they were made by some intelligent life. And so this whole notion of Martians and how that came to be is part of the history of started discovering and understanding Mars. But I'm going to take a moment here and show you where Perseverance landed. So if you wanted to, let me just get a little bit closer so we can see things. And I'm going to twist over this direction a little bit, because the 2 main sort of striking, most important features, I guess, on Mars are a gigantic volcano, which isn't exactly in the scene now, and a gigantic canyon. This is actually called Valles Marineris. And it's a kind of a scar that goes much of the distance. Let me do this. I'm just going to move forward a little bit so I can put I know I can adjust time as well. So I can put Valles Marineris in the center of your screen. You see this big scar right here, just sort of like goes across this direction. It's about 10 times longer than the Grand Canyon, maybe 6 times deeper than the Grand Canyon. So it's really, Mars is about half the diameter of the Earth, but it has these huge features. And you see these sort of roundish things coming into view. They might look a little bit like craters. They're just the opposite. They're actually mountains sticking up. This big one over here is called Olympus Mons, and it is also a geological feature. It's the largest volcano that we know in the entire solar system. So there's things going on. We've traveled to Mars a bit. I'm just going to get back over here, going to change time back again, and I'll show you where we're going to find the landing site. It's north of the equator, not on the equator. I'm going to move around and see this big, huge, dark splotch that's coming into the center of Mars there. That's part of the feature that I'm looking for. And I'm going to show you some images here in a minute, but I wanted to sort of, just before we get there, the Perseverance rover landed about right here. So this is a very, very large basin over here. It's not the Jezero Crater. It's a sort of a part of Mars that's sunken lower than the rest of them. And so right on the edge over here are some highlands, and then the Jezero Crater. So if you sort of imagine this area right here for a moment, let me get a little bit closer. The resolution of this all planet map is not really enough to see too clearly, but I'll get you a little closer. And so just again, we're looking at an area just right about here. Let me show you sort of a big image of what we call Jezero Crater. It's on my screen. It'll hit your screen in a minute. There it is. And so when we talk Jezero Crater, you can see from the scale bar down here, it's really quite large. So I just didn't scale it out before the show, but I'm gonna say 10, 20, 30, 40, I'll bet it's about 70 kilometers across. 70 kilometers would be about halfway to Tucson. So that's a fairly large thing. The ellipse, the little black ellipse in this particular scene was the intended landing area for Jezero. Let me just kind of end this picture. I'm going to bring up another one here real quick that just sort of like shows that area in much more detail. Just to give you a little sense of what that is. Here it is. So now what you're looking at is the crater rim off to the left side of this image. This is sort of the crater rim. And this is the feature that attracted scientists to this area. This is why a geological laboratory is important to land on this particular surface. You can see there's a little bit of highlands over on the left, and there's a definite striking indication that there used to be flowing water, actually large volumes of flowing water that came in out of those little highlands and filled in this area. We think this was an ancient lake bed. So as Pauline was explaining some of the instrumentation and some of the things and some of the tools we're going to use to analyze the soils and the mineral content and all that stuff, what we have here is the edge of a crater that has delivered material over time. Most of this is ancient, very, very ancient. These formations are billions of years old. There is no active water movement on the surface today, as we know, but it still gives us a chance to see not only an ancient lake bed, but also some more recent arrival of more material after the lake bed was established. And that's really important. So if I have I looked at some websites today, and I'm going to suggest, somebody could probably prove me wrong, that the Perseverance rover landed just kind of like in this area right here. And the total of travel for the rover is going to just kind of take it up and into these little sort of lower hills here and up in this particular direction. They don't know for sure. This is sort of the target. This is the way they want to head. This is the way they want to attack these geological formations, is sort of like to head up in this particular direction. But they're going to learn as they go. So part of the idea behind all of the instruments and all the cameras that are on board is so that they can find interesting things out in front of them and then organize to drive the rover to them. So they'll be choosing their science, choosing their targets as they go, and that will take them indeed as planned in this particular direction. So that's a little bit how that is going to work. I am going to lose that in now. I just wanted to show you another way to look at the surface of a planet. So this is it's just kind of a rudimentary, sort of low scale view of the surface of Mars and what it looks like. But there has been a Mars orbiter orbiting around the surface of Mars for almost 2 decades now. And on board that thing is an instrument called MOLA. So I get my chance to do an acurism. MOLA stands for Mars Orbiter Laser Altimeter. And its sole function, that instrument, is to just basically map the surface of Mars in altitude. So it is an altimeter, it's laser driven, and it basically has given us a very, very detailed scale view of Mars and exactly the heights of things. And so this particular map is also color coded. Bluer things, and you'll see purple when I go around the bend here a little bit more, is going to be lower areas. Mars does not have an ocean. It sort of looks like an ocean here, but Mars does have a nominal level, sort of a nominal altitude. And so we measure things below that altitude, just like we would on Earth, like sea level or below, or things above that particular altitude as highlands or heights. It's different from the Earth because, of course, there's no water involved. But remember that gigantic scar I was telling you about, sort of Valles Marineris? Look at it in this particular view. And so it is been the process of studying a planet or any kind of moons or asteroids that typically the first thing we do, oops, sorry, I set my thing to leave the planet here. Let me move back a little bit. The first thing we do is do flybys, just kind of get a sense of, what the surface looks like. Then we launch equipment to do an orbiter, fly around it and around it and around it and image it and use these altimeters and these instruments to understand the surface. Or that spectrometer that I told you that was on the United Arab Emirates mission, that's another instrument that would be reconnaissance oriented, where we'd understand the surface and the geology of the surface from space first. And then that is how we organize to pick the landing sites, because it's very, very important. You want a place that's going to be safe enough to land a very, very expensive spacecraft, but you also want a place that's going to be scientifically interesting. The reason to go there is to generate some science. And so, so over the years, we have discovered a lot of interesting places about Mars. And just now, the adventure begins at Jezero Crater. And we're going to use it to discover this geology. And then I can't stress enough, Pauline mentioned it, and the documentation of the Mars mission, we'll mention it over and over again. This really is a mission with the principal investigation to discover if there was past life on Mars. So, we don't believe, as Pauline indicated, we're not going to find bone. I don't know, but we're not going to find bones. We're not going to find teeth. We're not going to find those things like we would think of a paleo Earth. But we still can determine chemical structures that happened because life existed, maybe millions, maybe billions of years ago on the surface of Mars. And those things can be found, and we can determine by analyzing those that there might be life on Mars. This is just a different view of that basin, and this is Jezero Crater right here. You can see where my arrow is pointing. So it gives you just a little sense about where it is in the scale of the other missions and where that goes. I have one more image I'm going to show you here, and it'll give you a little bit of sense of landing sites that we've sort of used in past. It just take just a little bit to get this one up. And so you can see here, this is that big, huge sort of dark hump thing that I was showing you a little bit earlier. And this name up here is Perseverance, and that shows you where that one is. The Curiosity rover is actually over here. This question came up last week. Are they ever going to see each other? Do rovers ever like go out there and meet in the middle? Or have we yet gone to a place where we can discover the remains of a rover that was on Mars? We don't, and this one isn't. And so now they're far apart, and they're separated across the missions are separated across the planet to get as much sort of back to that scientifically interesting sort of places. So you can pull up a map like this and just see readily what's where and how it works. Okay, I am going to take a bit of a break. I'm going to kick it over right now to our students who are prepared to kind of take a little break, ask some questions, or ask some questions from the audience, and do some polls. And then I'm going to come back. I'm going to show you, essentially, I'm going to direct you into a website where you can see our images, or I say ours, but the images from Mastcam-Z, and where you can find them on the internet, and how you can watch them come in, and how you can sort of like learn what we're learning as we learn it on the surface of Mars. Okay, handing it back over to the team. Thank you guys very much. Hi, Alex.
Right. Thanks, Rick. Let's see, 1 second. Okay, so we're gonna launch a poll regarding some questions. So we're gonna start with the first one. And the question is, what are some of the new technologies on the Perseverance rover that are not on Curiosity? You have the ability to capture audio. You have 2 zooming visible image cameras, Martian sample collection and storage device for future sample return missions, or all of the above. And so while you answer those questions, we might have some live questions if Spoo has any. Spoo?
Yes. Thank you, Alex. So I'm gonna give like a background story of this question because it's a two series. It's a 2-question series. So the first question asked was about Moxie, the converter of carbon dioxide to oxygen on Mars, and Chris is curious if since we can convert CO2 to oxygen, is there any opportunity for bringing back the previous Mars rovers back to life, and can we use that as liquid propellant, and can we use it to hypothetically reduce the cost of a mission or the cost of a return mission, so that it can bring something back to Earth? So that's a very good question. And honestly, that could be possible. Moxie is preparing to experiment converting carbon dioxide on the surface of Mars to oxygen so that future missions can. So we just need to carry an empty oxygen tank and get it to Mars and then fill it up on Mars, and that'll reduce our payload and the whole cost. So this is a very good question. This technology can actually aid reducing the cost of future missions. I don't know to what extent right now because the technology is kind of new and it's still being experimented on, but it's definitely something that we can look forward to. So the answer to your question is yes, it will definitely cut down some cost for the future missions, and return missions will be easier. So that's a very good question.
Okay, so to the poll results, most of you got it right. 90% said all of the above, and that's correct. Perseverance has all these new technologies, so there's going to be a lot of exciting new information that these can all help contribute to the study of Mars. We have another question. I'm just going to launch this real quick. What's the name of the helicopter drone that accompanies Mars Perseverance? It has a drone buddy that's with it. Is it Hope, Opportunity, Ingenuity, or Perseverance Junior? So it looks like we've got a pretty large majority for one answer. And let it run for a few more seconds. Okay. So a lot of you, the majority of you said Ingenuity. That is correct. Some of you also selected Hope and Opportunity. Those were some other Mars missions, but they were not the Rover. And then Perseverance Junior wasn't.
It just sounds like Alex to me.
Yeah. But Ingenuity is the name of the helicopter drone that's accompanied Perseverance. And then for our final poll, we have, what is the name of the Mars Perseverance landing site? We have Jezero Crater, Olympus Mons, Valles Marineris, or Gale Crater.
Whoa, that's quick.
Yeah, we got, you guys must have been listening. That's good.
We have a savvy audience. I think they've been following, so this is really
That's good.
This is excellent. Yeah, I'm really anxious to see the little helicopter Ingenuity fly. If I understand correctly, I'm certainly not that much of an expert on the mission, but if I understand correctly, it's going to be a couple months before we get that off the ground, and it doesn't necessarily have a big science mission. This is the reason it's there is just to see if something like that works. If we can actually sort of like get something like a drone. It only weighs about 4 pounds. It only holds like 2 cameras. And that's it. There's no extra sort of things. It's solar powered, and I think, and it actually drops out of the bottom. It's kind of up in the belly of the rover. It will eventually sort of like be released, drop down to the ground. The rover will drive away from it, and then it will activate and see what happens. I'm kind of excited about that one as much as I am just about anything else as well. So any other questions? Go ahead.
Just real quickly, majority of you said Jezero Crater. That is correct. Gale Crater was the landing site of Curiosity, and Olympus Mons and Valles Marineris are two it's a volcano and, of course, the canyon that we talked about earlier. But those are our poll questions.
And congratulations to everyone who sent their names to Mars. We have our names on Mars now. Yeah. That's another great thing.
Oh, that's right.
Right.
Okay, so what I'm going to do is, Spoo, I'm going to call on you in a little bit to share that image of the, not exactly yet, but get ready to show the image of the the calibrator, the image calibrator that's on there. So everybody, oops, I didn't launch my my thing yet. Hang on a second. I'm actually going to do live. I'm going to show you exactly how to find information about. So you're looking at the internet live on my computer as I'm showing you how this works. I hope everybody can see this. Yep, I think you can. So this is essentially just, if you Google NASA Perseverance rover, if you Google anything like that, you're gonna hopefully get to this particular web page. This is the thing. You can learn in here a lot about the mission and the timeline and the spacecraft and all that stuff. But here's the direction I'm going to send you in. I'm going to point you towards multimedia. is the thing. And I'm going to like drop you down to this thing. Now explore all of this. Don't just do what I'm showing you, but I'm going to drop you down to this thing called raw images. I clicked it and here we go. And you'll see here an image of the week. I think many people will recognize this first one. That was actually the very, very first image that came back from the rover on the surface. And you see how it looks a little blurry and all that stuff. There's still some dust kind of in the air from the landing, but there's also a protective covering that hasn't been removed from the lens yet. So it has this little sort of film over the surface that comes off later, and then these images become a lot clearer. But this is it. This is sort of like, this is some of the cheers that we saw during that landing is when we get something like this. And I should also say, you remember when I was showing you the distance from Earth to Mars and all that stuff, and it's increasing, right? Earth is moving faster every day, every minute. We are getting a little bit further and further and further away from Mars in the way our orbits work, and it takes some time. It's a little bit over 11 minutes right now for the rover to start sending some data to us, and when we actually get it. So 11 minutes doesn't sound like that much time to receive research and data, but it was a long time when we're landing and we want to know, and did it make it and all that stuff. It just, we had to wait for it to get there. Okay, down here, you'll start to see just a collection of images, and it's pages and pages of images. But this is the special space. You can filter by different kinds of cameras and different kinds of things. They're going to set this up for you. Right now, I'm just going to check these two boxes, Mastcam Z left and Mastcam Z right. And that's the magic. So if you're kind of interested in what we're doing, what ASU is actually actively working on within this mission, we are receiving these images. They come down to Earth. They get routed to us. Those young ladies that you saw inside when we very first started this program, the young ladies you saw in that glassed-in room are the ones that sort of like receive these things. They calibrate them. They check that they're the amount of pixels they're supposed to be. They throw away some things that don't work right. They label them, they get them back out into the science community as we go. So these are great. And so this actually, what I really like about this is when we can have programs like this, all this images were released maybe less than 48 hours ago. So there was on Monday, maybe a little more than 48 hours ago, on Monday, there was a press conference by NASA, and they started releasing these images. And can you imagine? I mean, there's people like Jim Bell that have been working on this particular project for years. And then, after a while, you have to give up the cameras. They put it on the spacecraft. And you can't do anything until it launches, and then it launches, and you have to wait 7.5 months for it to get there. And then finally, the first images that we got were actually of the craft itself. The cameras were pointing down, and then the arm lifts up, and we can start to look at the landscape. We can start to look at rocks. And first images took a lot of pictures of itself, as you can see here. I wanted to show you this here. I'm going to kind of just zoom in on this image just a little bit. This is actually an ASU thing. So there's a little color strip here, and then there's this little thing on the surface. If you don't mind, I'm going to stop share real quick. Would you just show your images? I want people to sort of see what that looks like in detail. This is a model of that little object when we have it down when it was down here on Earth. And do you have another one that's just a little bit? Yeah, there it is. That's sort of what I wanted to show people. So and what I learned, and I didn't know this before this, but you don't see any big, huge logos. You don't see any big, huge names and things kind of scrawled across the Perseverance logo, but it is actually embedded. There's all kinds of little scripts, and a little bit of sayings, and some writing, and some tributes, and the names of people that submitted names to sort of like fly up to this thing are on there. And so researchers do have, and scientists do have the ability to kind of just put some little sort of notions and tokens and things like that embedded in their products and in their science on the rover. So this is a calibration thing. You can see there's a shadow, that's important. You can see there's a grayscale, that's important, and you can see that there's some colors. And we use this to essentially calibrate the cameras wherever they take pictures. And so oftentimes there will be an opportunity for the masthead to swing around and then focus on this little calibration stick or wheel. And that helps the organizers do that. Thank you, Spoo. I'm going to kind of reshare my screen now, if I can. Anyway, I wanted to show you that and this particular website that you need to go to, and you can follow it. And I was just going to just go back to the beginning here. Raw image of the week. Back to filters, remind you, use Mastcam Z, right and left. Remember, there's two cameras, so they differentiate. And so the other thing that's important about these cameras, and then I'll leave this and we'll kind of get away from Mars for a little bit, but it sees, it's a zoom camera or twin zoom cameras. On Curiosity, there was a far field camera and a narrow field camera. So one was a big wide angle and one was a narrow angle. And they were the two cameras that are on each side of the mast. The improvement years later for the Perseverance rover is that they're both zoom, so they can operate together. Dr. Bell mentioned last week, as we were sort of doing their program, he said that the zoom function of these cameras, the long range resolution of these cameras, is that you can see over 100 meters away, that's the length of a football field, and then some, you can identify a horsefly on the wall. Now, there are no horseflies on Mars, but that's pretty amazing. So the cameras have that ability to see distance and in stereo. So we can actually sort of examine the three-dimensionality of a rock or an object or a point of interest far away and very, very close. So they zoom out wide so they can actually examine the spacecraft or the rover itself, checking for problems and issues, and it can look at the landscape. And you see both examples here. So I was pleased to see this when these came down, because you get a sense that that they've tested both ends of that spectrum. You see these long pictures out to the horizon. And of course, you can see a very, very short throw, just kind of the rocks that are right under the spacecraft. And that's what it's intended to do. And I'm just thrilled, as everybody else at ASU is thrilled, that this is working and these cameras are operating, and we're getting these now that these images are being released. Follow it, follow the progress. Just watch these all the time. Head for the Mars Perseverance website, head for multimedia, head for raw images, and you'll see the stuff that we're working on every single day. And so that's a really, really good place to leave that. The next thing I wanted to do is, let me see if I can do this. One of the images that came down that I guess we should be very, very proud of. Let me see if I can get it back on the screen here. Here it is. Here it is. I have to share again. One moment. Is what they call a 360-degree panorama. Here it is. And so this is a little bit deceiving, because really what you're looking at is a full circle, sort of end to end. The left end kind of meets the right end. I spent some time this afternoon actually putting that panorama into our software. I basically kind of ran it onto a little cylinder, and we're going to be inside the cylinder. And let me just share that with you for a second. We're going to be inside the cylinder, sort of looking at. Now, this is a little bit oddly shaped because my system is a planetarium system. It's designed for a dome, after all. And so it's going to look a little bit sort of like warped and all that stuff. But this is that image I was just showing you. But now let me just sort of pan around, a little 360-degree movement here. And you'll see it actually goes around in a full circle. And all the gear and equipment that's in the front of this image is the rover itself. You can see one of the wheels coming by there. I'm going to pause for a moment when we get to a good image of the back of the space or the rover here. Check this out. So so you can see the cameras now are sort of focused at looking backwards. All right, and see the back end of the Perseverance rover, and then you see the landscape going all the way out to the horizon. That little strip across the top, so that the dark stuff is the edge of the image, so it didn't take any image above that. The little sort of lighter strip is the atmosphere, that's the air, that's the sky of Mars. And then you can start to see little sort of mountains and hillsides in the background. I'm just going to kind of keep going around so you can get a sense of the movement of the cameras. They spin all the way around, sort of like an owl's head. That big mass right there, kind of attached to the front of the rover, is actually the head of the arm. So remember, there's like an arm maneuverable device out there that has instruments on it. It hasn't, as of this particular image, been deployed yet. So I assume they have done that since, or they will do that soon. And we'll see how that arm works and make sure that all of its functionality is there to sort of see. You can see here where the strips come together. That's where one end of the image meets the other end. And it just kind of goes around and around and around like that. We're kind of excited in my department, in the community outreach rather, but the room behind me, the Marston Exploration Theater, the one that sort of you see in my background, is a 3D theater. And so we have done this with Curiosity. We'll do this with Perseverance. We can actually take a left eye view and a right eye view and load them into the system in the Marston Theater and wear these really cool glasses. And you can actually see in 3D, it's actually see the depth of Mars, and we can see what that looks like. So as soon as we get back next fall, we'll probably have public programs again. We'll be talking about a lot of the things that happened while COVID was going on, and we'll be able to kind of test out some of this technology and see some of these 3D images right in our theater. That will be very, very super amazing when we can. All right, some preview of some things coming up. I can see that we're right at the 8 o'clock hour, so I don't want to hold you up any longer, but I do want to kind of send you out into the night sky, because that is something that we try to do. Recall, if you've been following along, 2 weeks from now, we're going to go back to the night sky. And there is a really nice, wonderful cluster of very, very bright stars in the sky right now. They include the constellation Orion, very easy to see. And if you look sort of north of Orion or up higher in the sky than Orion, you're going to find that there are dozens of very, very bright stars. And all of them have a little secret behind them. All of them are individuals. All of them have a story to tell. And what we're going to look at specifically next week is color in stars. And kind of you can see, if you look deep enough, you can see different stars have different coloration. That's the surface color. The temperature of the star is reflected in the color of the star. And we've invited an astrophysics professor in our program named Dr. Patrick Young. He will be the guest, and we'll be talking about those stars. So get outside and look at the night sky, especially identify Orion. I'm going to give you something to look for. Look at Orion, look at this upper shoulder, and you'll see it's a very red star named Betelgeuse. Look below the belt, the 3 belt stars in the bottom edge, and that will be Rigel, and it's very, very blue. And so take advantage of this particular time of year with these bright stars in the sky, with Orion prominently placed, and just kind of check that out. Get a sense of what you're seeing, color here and color there. We are going to break that down even farther. There are about 8 to 9 types of stars, and the type relates to the color of the stars. We're going to just kind of pick them all. And Patrick is going to give us a little sense of what's happening when we see that, what's going on at the star, what's it doing, and why do we see the colors we see. So that'll be kind of fun. 2 weeks after that, it will be springtime. Here we go. Winter it seems like it just hit, and now it's going to go away. So we're going to talk about that vernal equinox and what new spring means, and why is spring when spring is, and what is actually happening in space to sort of designate the moment of spring. And we'll talk about that now, and we'll talk about that historically, because it has changed a little bit over 2,000 years, and look at some other constellations and some stars. So coming up in March, it's a month about stars, color in stars, and then spring equinox, and a whole new set of stars coming up in the night sky. So we'll do that. Later in April, we're going to actually turn towards the Earth. We're going to celebrate Earth Day. April 21st is our program. April 22nd is Earth Day. We're planning on our program and having a guest geologist talk about what's happening around the Phoenix area and what to look for. Arizona geology is going to be the focus. And then the next day, we are planning a new discoveries lecture series, a whole different kind of talk. It's a program, and hopefully some guests, and we'll celebrate Earth Day then too. So lots to look forward to. Please respond to the survey that Kim is going to send you within the next day or two. That helps us understand what's going on and what people like and what people don't like, and some of the things that you'd like to see in these programs. We'd love to hear from you, and don't forget to tell your friends and everybody, and especially your teachers and educators, about the programs we have and how we can be of service to you guys. Thank you very much for attending the virtual night sky, and we'll see you in 2 weeks. Thank you very much. Bye-bye.